Hello, everyone, and welcome to today's SANS webcast, How to Create a Comprehensive Zero Trust Strategy, sponsored by Cisco. My name is Carol Auth of SANS, and I will be moderating today's webcast. Today's featured speakers are Dave Shackelford, SANS Analyst and CEO at Voodoo Security, and Tim Garner, Engineer, Product Team at Cisco. If during the webcast you have any questions for our presenters, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to our presenters.
Fantastic. Thanks, Carol. And hey, thanks everybody for being here with us today. I'm Dave Shackelford. Super excited to be here with the team from Cisco to talk about the topic du jour, right? Or certainly one of them in the security industry, which is zero trust. And what you find is, depending on who you're speaking with and, sort of the perspective that they're taking, zero trust can mean a lot of different things to different people in different organizations. And so I think it's kind of useful to take a step back and really distill what we're seeing in sort of the enterprise and really speaking as a SANS instructor and analyst, somebody who's I'm constantly talking to folks just like you in class or, during different types of research projects. And it's always interesting to hear that feedback coming back from the community. And certainly the folks at Cisco have a long background in developing these kinds of technologies and helping organizations to build out zero trust strategies too. And the cool thing is, if you had said to me, hey, zero trust, Dave, 10 years ago, I probably would have been a little skeptical just because I'm not 100% sure the technology had caught up to us. Really, I think we've all got sort of buzzword fatigue in the security and really just the infrastructure industry altogether. But today, it's 2020, things have rapidly accelerated in a number of different places that I think facilitate making zero trust imminently more possible than it ever has been in the past. So that's pretty cool. And the way I look at this as a security professional is, it kind of comes down to two core pieces of the environment, right? Zero trust, if you kind of distill it and you look at the technology stack that's helping you to move towards that, it tends to be somewhat network focused. So networking is a big piece of this. And it also tends to be very centric in the world of workloads. And that could be servers, that could be, virtual machines or cloud-based systems, all of the above. Certainly, the nature of the environments we're dealing with today is, sort of much more hybrid in nature. But if you're looking at how we try to get to zero trust, those have to be the biggest pieces of it. Now, that's not the only side of this, because certainly we also need to be thinking about just redefining the whole notion of say, perimeters. Some people have said, this has been such an interesting trend. Coming from a networking background, I started my career over 20 years ago, and the whole concept of the perimeter was pretty well baked, and it was even, more well so in, I'd say, the first couple of years of the 2000s, where, if I said perimeter security to anybody, they could immediately kind of get this, mentality of the, kind of bullseye diagram, where we've got this external perimeter of the data center, and then maybe you've got various sort of segmentation or isolation zones within that environment, and that could be sort of a sub-perimeter. And to some degree, that concept still holds a little bit. But what we've found is that, the environments we're dealing with, it's just not so crystal clear, right? It's not everything inside is trusted and everything outside is not. And that's been the case for a pretty long time. I think we came to the realization, easily a decade ago that it's probably better to start, casting a wary eye towards the internal side of things as well, just given what we know now. There's a lot of more sophisticated attacks where these guys are definitely taking the time, doing the low and slow model versus, getting in the environment and sort of banging around, making a bunch of noise. And that means that we have to treat pretty much the entire spectrum of network infrastructure, both internal and external, as semi-trusted or untrusted, and work from that perspective, right? Instead of thinking of the outside in, we have to start thinking about the actual assets that we're dealing with and start building out perimeterization models that focus more on that. Now, all that said, it sounds great, right? That sounds like a lofty thing to proclaim, standing on the podium and going, this is it, this is how we're going to move forward. But it's not that simple. because there's a lot of other things that have to kind of dovetail in here in order to facilitate this. And that includes things like system to system relationships, entity relationships, user relationships. So there's some identity that's sort of the glue built into a lot of this as well. There's also behavioral profiling of what's running in the environment and what's running on these workloads and across the networks that we've never been really good at detecting and really building out profiles for. So today, again, here we are, it's 2020, all of that has changed. We've seen lots of technology shifts that have facilitated getting closer to that model. And really, those are the building blocks of zero trust. Now, I'll just be the first to tell you, I'm skeptical if anybody says you can check one box on, a technology and just immediately achieve zero trust. It's a goal to work towards. And some technologies, of course, can help you accelerate that dramatically and move towards that. But it's always going to require some understanding of your particular subjective environment, what's running there, how things are intended to be interrelated. So there's always some things that have to be done. And no technology can just inherently give that to you. But all of these pieces that I'm talking about together can certainly work towards getting us into a zero trust model. So what is zero trust, right? I mean, if I had to say it, I would say the zero trust model is one where all of our assets are basically starting from zilch, considered untrusted until we have validated something about them. And that something, as I said, tends to be network traffic and application behavior, and services that are running and all of those sort of conjoined pieces that go along with workloads and assets in the first place. All those things have to be somewhat sort of cohesively combined into a this is good or not good. But we start with the perspective of nothing's trusted. Let's build out our model of sort of monitoring and essentially looking at that perimeter in a completely different way. So you're going to start seeing things like microsegmentation. You're going to start seeing things like identity controls really becoming a major element of not only the perimeter, but how those behavioral definitions are constructed and policies around them are defined. So there's a whole bunch of stuff that starts to come together. But again, you need newer technology to really be able to get towards that. You can't just rely on things that we built, 20 years ago or 15 years ago and try to sort of, MacGyver it or duct tape it into a zero trust model. It really just doesn't work. So a couple different elements of this, right? Number one, and as I said, what we've kind of seen, which I think is interesting, and especially in the age of cloud, and I spend a lot of time talking about cloud in all facets, both private clouds that have been built on premise, as well as certainly the public cloud environments that are out there. And what you've found is that we've gradually been moving security orientation back towards the workloads themselves. And I think that's fascinating. I mean, I've definitely watched that pendulum swing in the industry, and some of you I'm sure have as well, where I think for quite some time, we, obviously patching and configuration, like none of that stuff went away. But I really feel like we sort of oriented our security focus more towards the network for quite a long time. And that doesn't mean that the network security goes away at all. That's still got to be, where we built it up to. But we're seeing more attention being paid towards the definitions of what those workloads are, how they're supposed to operate, and then building out, again, security models around them. So I'm seeing that sort of almost micro perimeterization coming back to the workloads. The second thing that really has to be done, and I mentioned this a second ago, we've got to focus on behavior. This is not new, right? I'm certainly not telling you something that you probably haven't heard at some point along the way. I do remember years ago, I started my security career predominantly in the network space, as I mentioned, but focused on network intrusion detection. So I was an intrusion analyst, predominantly, again, looking at network traffic. And back in the day, it was pretty much all signature-based stuff, right? You built various types of signatures to look for bad things happening in the environment. And, a few years of that, we started to realize that alone wasn't going to cut it. Doesn't mean it doesn't have merit, but, we really have got to start looking more towards behavior of the environments. And if you guys are in a big shop, right, if you're in a big global enterprise, that is not an easy task. And so behavior, even today, is not always the easiest thing to intrinsically gather and build profiles for without some really significant effort. And again, some new types of tooling that can potentially help us get there and get there quicker. So those things have to happen though. So in order to start moving into a zero trust model and building out zero trust profiles, number one, got to think about workload profiles and policies and security around the workloads themselves. And number two, you really need to be thinking about behaviors holistically, not just at each workload's level, but in terms of the interaction between various sets of workloads within particular network contexts too. And that is a big task. I mean, there's no way, you're going to get to a zero trust implementation, even like a sort of small sort of zero trust model. Like in other words, if you're trying to say, hey, look, this one part of our environment, we're going to start working towards zero trust in that part first and then sort of spread outward, which is, by the way, a pretty good strategy to, sort of get things in order. But it takes real dedicated effort, right? You're going to have people invested in this. You're going to have stakeholders that are supportive of these kinds of efforts, because not only is it a radical shift in the way that we design and build out our infrastructure, but it completely changes the way that our policy implementations are not only enacted, but maintained operationally over time too. So there's a whole lot that has to change in order to get to this. So let's start with some of the big pieces. And I think one of the things you have to take into account is user identities, because, let's face it, what's the whole idea of IT and why it exists in the first place? It's to facilitate users doing things. Those users could be customers, those users could be your internal users, some combination of the two, but you need to understand the context of how your user identities are being integrated in. And so, number one, we got to think about what people are doing and where they're trying to go and what things they're trying to get to and whether any of those are appropriate for the types of user roles that we have in place. So, again, you have accounting applications that need to be accessed by the finance team and the accounting team. You have HR file shares and HR data sets that need to be accessed by those users. So bringing in user context is pivotal in starting to move towards zero trust, especially if you're keeping that least privilege mindset, which of course we should. But that means that you're going to have some visibility into things like user directories. You're going to have some visibility into, maybe federated or single sign-on access controls, especially if you're moving into a lot of cloud services. You're going to have to accommodate for things like, various access control models, like where are people coming from? And today, that's a really interesting discussion, especially since we've all been remote for a length of time now. It's actually fascinating to look at this. I've seen some organizations during the past 6 months, and we all know what's been going on the past 6 months, right? Where, previously you really relied on people to have had their traffic or had their sort of source origination be in a known place. And now those places are completely different potentially, especially as people are working from home. So the idea of access controls is definitely back up in the air and open for discussion. And then authentication and authorization controls. So all of the key themes that go along with just identity and access management altogether, IAM, that has to be a part of zero trust. It has to be accommodated for in the way that we build out policies related to behaviors. Number two, it's device identity. And these things kind of go together, truthfully. I mean, you're looking at, endpoints and the origination of end user traffic or where they're coming from. And today, I mean, given the nature of how organizations tend to function, I mean, certainly you have lots of mobile devices and laptops that are, scattered around all over the place, but you've also got things like virtual desktop infrastructure. You've even got cloud-based virtual desktops and remote desktop type scenarios that are starting to gain some traction in the enterprise too. And all that does is potentially complicate it, right? So you have to look at all of these various sort of locations from where the originating sort of data access or system access or application access is coming. And that has to be included in your identity orientation. Again, what types of devices are allowed to connect here, or those that are not, where should they be coming from? So it's the user, it's Dave. Dave is in the security team. He can do X, Y, and Z. But it's the devices that Dave is coming from. Those things combined tell a much more compelling story about identity altogether than just one or the other in a standalone fashion. So good zero trust policy enactment should take some of this into account. Now, the third piece, of course, is network access. And a lot of times when you say zero trust, this is the first thing that kind of comes to mind. People tend to naturally gravitate towards network traffic or sort of network data, which is fine because truthfully, that is what we're building profiles around. We're observing patterns of traffic between systems. That's going to include all the standard fun and excitement of things like ports and protocols, traffic types, and the patterns of those traffic types. But it needs to get even more granular than that. Because remember, now we're dealing with the actual behaviors of the workloads themselves, which means if you're really trying to dig deeper into, say one system communicating with another, and you could take an easy example, some sort of a web application infrastructure. So you've got things like, kind of your front end presentation tier, which might be Apache or Nginx or some other sort of web services. And then you've got some application services, maybe database or data store services. And all of those have to work in conjunction, but there are defined patterns of communication between those, hypothetically 3 different tiers that should be understood. So what types of ports, what types of protocols are being observed? Is that okay? Yes or no? And then it's the application behaviors even down to elements of the workload. So in other words, is Apache running from a specific daemon or specific service orientation on that workload? Or is something else running that looks a little fishy, right? So you start looking at that at a combined level, and it's a lot to take in. But the network traffic and the network access from asset to asset and users accessing specific assets and ports and services and so forth, huge part of a zero trust mindset as well. So this is where you're going to start seeing this term microsegmentation come into play. And the whole idea of microsegmentation, so I've come full circle, by the way, on this, right? I am a professional skeptic. That's actually, I should get a business card made that says that, right? Because truthfully, I feel that way, just in the technology space. I'm like, look, I'm a skeptic until proven otherwise. And when people started sort of, talking about microsegmentation a lot and using the term, my immediate attitude was, all right, sounds good, right? I mean, it all sounds good until it doesn't work. But this one is one that I think it has stuck, and I've actually become convinced that the concept and the tools needed to implement microsegmentation are here to stay. And I'm pretty excited about, especially sort of the shift towards the software-defined data center and the use of heavy-duty converged infrastructure on-prem, perhaps, and then of course moving out into public cloud environments. This is all software fabric that we're kind of integrated into. And you have a lot more capabilities to implement microsegmentation than we ever had in the past. And so this is, of course, looking to ensure that we're building out those, sort of micro perimeters. So each workload is sort of an island, the way I think of this, right? And then you're like, well, which islands can talk to the others? Let's start taking a look at that traffic pattern and all of the various elements of what's going on there, and saying, okay, this asset can talk to this asset. We've decided that they're part of a trust group, for example, but they can only communicate on these ports and in these ways, meaning if an attacker pops one of your systems and starts, fishing around in a discovery exercise of their own to try to find new assets and targets, which they will, their patterns of traffic aren't going to match those that are known and trusted. Thus, you're going to start seeing things like unapproved network connections. Right, you're going to start seeing attackers reaching out, via SMB or trying to log in or authenticate to places that they just have absolutely no business doing so. And that's going to help us start to detect things like lateral movement and that illicit network activity that does come down to an understanding of the patterns of behavior that we've observed and, of course, ostensibly approved within our environment. So the whole idea of microsegmentation is the right one to be able to really start getting us towards a zero trust idea and concept, but it requires so many things in order to actually work. And this is my list of stuff that I've just heard consistently out in the industry. When I'm not teaching and working and doing research, I'm a consultant, so I'm out running around in data centers these days, virtually running around in the data centers, as we all are, with clients and talking to them about what's going on and what they're thinking about and what some of the struggles have been. And some of the things that I have found really acting as kind of the roadblocks towards getting into a zero trust model are listed here, right? And I think everybody can understand some of these things. I mean, number one, too many disparate pieces of technology that just don't play well with one another, silos of technology that, you've got to maintain for some indefinite period of time. legacy technologies and things that we just can't get rid of quickly. A lot of rapid changes in the threat landscape. I mean, the attackers are getting better. They're certainly able to move faster than we are in a lot of cases. We know this. Lateral movement, that whole east-west traffic conundrum that's been plaguing us for years. Yeah, I mean, people are like, look, I've got thousands and thousands and thousands of systems. How am I going to detect insider threats or lateral movement or what have you? Right? I'm not sure how I'm going to get to that in the density of our environment. And that's been, something that I think people have really struggled with. And then, of course, let's face it, not all the technologies out there have been created equally. So some of it's tough to use. Some of it's really, sort of clunky. It lacks simplicity. It lacks ease of use. And I have firmly come to believe ease of use has to be a top 3 or top 5 priority for every major technology purchase, especially something as big as this. So if you're looking at technology that's supposed to be able to help you get towards this massive sort of philosophical shift in the way that you construct your infrastructure and maintain it, it can't be, so complex that it takes 86 people 2 years to be able to put it together. It's just not, that's not practical at all. And of course, just being able to deal with those new technology requirements sometimes is tough. And that might just be budgeting, or it might just be some, really lack of innovative mindset in the environments that you're in. So there's tons of reasons why people sort of argue, zero trust is hard. My friends, let me be the first one to tell you, zero trust takes work. As I said, there's definitely technology out there that can move you a lot further down the field, but none of it is going to just clickety click and you're done. Because you've got to understand the environment, you've got to observe the patterns, you've got to stamp them as being good or bad, build the policies, integrate things across either your internal infrastructure or cloud infrastructure or both. These are big projects. There's no two ways around it. They're always going to be big projects. And they have a couple distinct elements that go along with them. Number one being discovery. So there's got to be a strong, critical. I'll just put it out there. Anything you look at acquiring to help get you towards zero trust has to have an amazing discovery engine that can find assets, find patterns of traffic flow, and find any sort of observed data sent between systems. And that doesn't mean that you necessarily need to see the actual data. You don't have to terminate every TLS connection and what have you necessarily, but you certainly need to understand the patterns of what's being sent and how. And it's got to be able to do so at massive scale and do so in a continuous model. No two ways around it. Those things, those are non-negotiable factors for a technology stack that's going to help you move towards zero trust. You have got to have a strong and robust discovery engine that can help you map assets and help you map data flows. Number two, when you move into the deployment, and the deployment's going to consist of a policy engine of some type. And that policy engine is going to be, essentially tied to an enforcement plane. So any sort of microsegmentation technology is going to have something that is basically where you interface as the security team and or network team or infrastructure team, whoever's going to be collaboratively working on this. But you're going to be building policies and observing flows and monitoring what's in the environment. But at some point, you're going to push those policies into being, maybe in a passive mode at the beginning, just to see what's going on, and then at some point enforcing them. And that means, once you found the identities, the users, the systems, started building out the mapping of assets and profiles, you should have an enforcement engine that gives you the coverage across the fabric of your environment. And so that deployment takes time. Again, certainly you want to be cautious in putting these types of technologies in place. And whether that's the technologies or simply the enforcement policies, again, a lot of people tend to start in sort of discovery plus passive alerting mode, just to say, okay, what are we seeing before we start actually locking it down? And that's safe, guys. Look, anybody that's ever put in a firewall or put in an intrusion prevention sensor or something that's in line, yeah, you don't want to start just turning that stuff on without really being comfortable with what it's about to do. Same goes for zero trust. I mean, any of these microsegmentation engines down at the workload level and or network levels, you need to be really comfortable with those patterns and profiles before you turn them on. The other thing that this should be helping you with is a monitoring plane. And I look at, any technology that's got this degree of visibility and coverage in the environment, as immediately integrating into your detection and ultimately response scenarios too. Because now you've mapped out what's going on. The better your understanding of behavior patterns in your environment, the better you're going to be to start seeing those needles in the haystacks and saying, that's just not normal, right? It's not usual for Dave to do X or Y or Z, or that type of endpoint or asset to be trying to communicate with this other one. And so I think detection, certainly just like enforcing the behavior of the environment is one major goal in any of these projects. But number two, it's building out more of a rapid detection strategy to facilitate you starting to respond. Now, again, response comes into play after this, and then that's a whole new category of discussion that you're certainly going to want to dovetail into, and that's not where we're going to go here. But I think logically, you need to have playbooks and you need to have workflows that tie into a response strategy. And this is a part of that, right? So you can certainly perform different types of response with a zero trust infrastructure. If you want to lock something down, or if you want to, potentially quarantine assets and those kinds of things, you can. What I see that as sort of like a secondary use case in most cases for the types of clients that I've talked to and work with. Most of the time, it's more about building isolation strategies, segmentation strategies, and then sort of that early onset detection model versus trying to use this technology as the response techniques and technologies themselves. It plays a role, but it's sort of like I said, a secondary use case. Now, all that said, there's tons of other interesting things to say about building out a zero trust model in the enterprise, right? And one of the things that people always ask me is, how does this tie into compliance? Like, what does this look like if I've really been relying traditionally on firewall rules and, network ACLs and switch port lockdown to try to convince my auditors that we're good? Well, auditors are auditors, regulators are what they are, but there's some great examples where these types of technology can really help. And these are just a few, and I'm certainly not going to, read all the factors on these slides to you guys. By the way, there's an accompanying white paper that goes along with this presentation, and lots of detail in that one as well. So very many thanks to the Cisco folks for sponsoring that. And we talk about this stuff. Like, look, if you're in the banking industry, in the financial industry, and you need to help lock down your SWIFT network, which is sort of important because that's where money transfers happen. These are examples of this, right? Understanding and limiting access in the environment, detecting and responding to threats, securing that environment. Microsegmentation can play a role there. Same thing for high trust if you're in the healthcare industry, right? Protection of remote diagnostic and configuration ports. That's a specific entry in high trust. Same thing with network segregation. Same thing with control of network connection controls. So in other words, how do we actually look at shared networks and, who's getting into those? Looking at, again, some of the other things in high trust, there's tons of things that apply here. Isolating sensitive systems, developing better asset inventories, controlling our technical vulnerabilities. I mean, all those things, a zero trust technology stack and approach has a very broad degree of coverage. And you can see that. And then again, here's my final example, just looking at PCI, if you're dealing with payment cards, if any of you guys deal with payment card industry, and I spend a lot of time doing this kind of work, it's all about limiting scope, right? The smaller the scope of that payment card environment, the better off everybody feels. And so, hey, that's one of the great things about zero trust technology is it can facilitate limitation of scope through segmentation models and controls. So lots of great things to sort of look towards putting these things, into the controls for compliance around. Now, that said, this doesn't mean that, let me go back one slide. It doesn't mean that you're going to just, click, you're compliant. You know that, I know that, we know that. But I've definitely seen a trend towards more understanding and more acceptance of these types of controls from the audit community and the regulatory community. And I only expect that trend to continue. This is sort of the nature of where things are headed. So if you're starting to plan for a zero trust model and roadmap, obviously it needs to start with that discovery exercise. And then you need to be looking at how your data moves across the network and how users and apps are accessing that data. And that takes time. And again, that's part of that discovery exercise to find those patterns and then basically start categorizing systems and applications and say, these are grouped together, these are grouped together, these have a relationship with these, they should be communicating in only these ways, etc. And so building out those asset identities and building out the relationships, you'll start to develop those patterns, but it does take some time to do that. And you certainly want to look for products and capabilities that ideally function across both internal and public cloud environments, just because that's, sort of where everything's heading. And if you're thinking about trying to build out the business case for this, really what you're looking at is sort of the, legacy technology stacks, if you will, that we've relied on to essentially isolate and segment things, and whether those are palatable and consistently capable of helping protect us, especially as our environment is rapidly moving more towards software-defined and virtual infrastructure. Not only that, you've got just infinite remote access and a huge diversity of endpoints and users, more so than ever before. Again, I don't like to belabor the fact that there's been a pandemic this year in 2020, but it has radically changed the way that people are working in a ton of organizations. And that's probably going to continue to varying degrees for the foreseeable future. So, you look at remote access, you look at what kinds of endpoints and users and so forth are coming from those different places. That's going to change some things. You're looking at, cloud and how that has to factor in. You're looking at changing business continuity strategies. How are you planning your business continuity and recovery capabilities and capacity going forward? How are you going to rely on newer technology that is better served to help build out rapid behavioral profiling? And much has been said about the whole AI and machine learning space, and I'm certainly not going to go too far down that rabbit hole. But let's face it, especially with some of the technology stacks in use and available to us today, you can do massive scale computing of behaviors and indicators and profiles way better than we've ever been able to do before, especially if you've got, terabytes of traffic or petabytes, all over the place. Being able to sort of flesh that out and rapidly crunch it down to say, this looks good, this doesn't, that is going to rely on some of those types of techniques. And that's definitely something that's going to become more so over time too. One of the things that I've had a lot of people ask me is, if you're going to be building out zero trust models and technologies, what are some of the metrics that you should be trying to chart and trying to actually track over time? And these are just some examples that I've seen sort of bubble to the surface, right, in terms of discovery, like how many apps are identified in map, what kinds of identities we're tracking and labeling, and that's network segments, assets, everything that goes along there. And then, of course, it's the changes over time, which are like the % reduction in access control alerting, compromised systems, reduction in incidents. I mean, those typically take a while to really build out, but certainly you're looking at charting and tracking the effectiveness of implementation of these kinds of technologies over time as well. And, look, to sort of wrap up and sort of look at, the nature of where this whole model is headed, it's going to continue to evolve, right? You know that, I know that. So I think we're definitely going to be seeing the technology improving and probably improving and changing rapidly. You definitely need a combination of tools and services to help get you there. Like I said, you might need some things that are in the cloud. You might need some things on-prem. You might need to make sure there's some integration with other tools and technologies that you still rely on and plan on keeping. But any zero trust architecture, it's got to include identity as a piece of this. It's got to include network access, and it's definitely got to have both monitoring and enforcement at the network and the workload level. So with that, I'm going to hand things off to Tim. Tim, take it away.
Thank you very much, Dave. And good morning, everyone. I found that presentation very, very interesting. It was awesome to kind of see you lay out the foundational building blocks as to what you might want to have in place to move to a zero trust architecture. And what I'm going to do now for the latter half of this presentation is discuss the Cisco product Tetration, which is a zero trust product, which is going to help you throughout all of the stages of a zero trust lifecycle, and kind of map a little bit around some of the more abstract concepts that were just discussed previously, down to some of the actual features and functionality of Tetration and how it can help you on that journey to zero trust. So for everyone out there on the call, like Dave was mentioning, Zero trust is not something that can be done in one click. It is something that is a journey that you're going to want to approach in a metered fashion. And it's all about picking the right tooling and the right technology out there to help you make that journey to zero trust without pulling your hair out and kind of like losing your sanity, because it is something that requires a good understanding of your data center, your applications, your workloads, your users. And let's go through this deck and really try to understand how Tetration can help you there. So I'll just take it over here. Hopefully I can. Here we go. All right. So before we can do anything, before we can start implementing zero trust, before we can start segmenting users from applications, application tiers from each other, you can't do any of that until you understand what is actually going on in my environment. And you'd be surprised how many times I walk into customer data centers, or like Dave was saying, less physical walking into data centers, more kind of virtual walking into data centers these days. It's a very, very common sight to not really have a good grip on what is going on in the environment. It was typically easy in the past to perhaps take some network choke points and to do some analysis of traffic data there. But as application model changes, as people push workloads out to the cloud, as we saw more distributed applications, understanding what is going on between those workloads, crucially that kind of lateral movement, the east to west data between workloads, has become incredibly difficult to have a good handle on that. So one of the first things that Tetration is going to help provide to you is deep visibility into what exactly your applications and workloads are doing. And the way that it achieves this is by distributing a small software agent out to your application workloads. So whether that's your Windows servers, your Linux workloads, your perhaps even AIX mainframes, you're going to be installing the Tetration agent there, which is going to be sending up a lightweight telemetry stream to the Tetration controller or the Tetration appliance, whatever you would like to call it. What's awesome about this is because it's an agent-based model, it's going to work wherever those applications are. So Dave was mentioning that, right? You need to be able to support data center workloads, on-prem stuff, all of the legacy things that you might have there. Well, maybe not legacy, but whatever you have running at the data center. Could be a physical machine, could be a virtual machine, could even be containerized applications. And in the same vein, you're also very likely to be having workloads out there in the cloud. Might be one cloud provider, might be actually multiple different cloud providers. So Tetration is designed to work in that hybrid environment where you need to collect data from everywhere you have and feed it all back into one centralized system and one single pane of glass. So we're going to feed that information up to the Tetration cluster, which can either be consumed by you as a customer as a service. So if you don't want to, ship any physical equipment to your data centers, if you're, just going for full as a service model these days, you can absolutely consume Tetration in that way, and it's a really quick way to get started. And all you're having to do is install software agents on your workloads. On the flip side, if you need to keep data within inside your own premises, or for some reason you have data residency requirements, of course you can install Tetration in your data center as a physical appliance as well and run it that way. In both circumstances, you're going to get the same capabilities to get that visibility into your public and on-prem workloads. Now, once we start to gather information, and we'll go into a little bit more depth around what that information is, Tetration is going to be processing that information. Dave was mentioning ML, AI, all of the fancy buzzwords that you hear from pretty much every vendor out there. And of course, Tetration is using those technologies. And I'm not going to try hype up, the machine learning capabilities, but the real kind of strength of Tetration is not the ability to do machine learning. It's actually the volume of data it collects and the ability to analyze that data consistently. So we are talking about huge volumes of data that are going to be able to help us build profiles about your workloads, about the users, about the access patterns, and then use that information to go back and control applications, control workloads, control access to those workloads. So it's about having a lot of data and the right amount of compute power to actually effectively analyze that data and give you insights to make changes on your network or to your application workloads. So what exactly is control in the world of Tetration? Well, typically that actually means implementing micro-segmentation. segmenting your application workloads from each other, from the users, from the different segments of your environment. And we're going to do that in a way that is flexible and can work across any different environment, whether it's an on-prem workload or a cloud workload. And we'll explore that in a little bit more depth around exactly how you can enact that control onto your application workloads. So let's map out a little bit around how we can use Tetration to build up this zero trust model. So as Dave was referencing in his presentation, one of the most important foundational building blocks of a zero trust architecture is to understand, what is actually out there. And really the best way to do that is by using some sort of database that has knowledge of your applications and your users. And so you really want to capture both sides of the house. What do those application workloads look like? If I have, labels applied to it in vCenter or in AWS, or if I'm using a CMDB like ServiceNow that has extra information, metadata about my application workloads, Tetration is going to be able to suck up all of that useful information and tag it and apply it in what we call an inventory. So here, for an example, on this slide here, you can see that there's a workload that's represented by an IP address. Now, IP addresses are useful, obviously, when we're talking about network constructs. But when you're starting to think about segmentation, zero trust, really at the end of the day, you probably actually want to throw away IP addresses and start moving to metadata that actually represents what that workload is, profile of the workload, the behavior of it. So by being able to pull all of this information in an automated way, you start to be able to use that information to describe your zero trust policies. If you want to take the example of PCI compliance, you can tag workloads that are part of that PCI scope, and then you can assure that they don't speak to anything outside of that scope, for example. No longer do you have to talk about IP addresses, subnets, and so on. You're just talking about the identity of that workload. At the same time, it's also really useful to be able to understand the users, the context of the device that's accessing an application. Is this user authorized? Did they authenticate to the network correctly? What Active Directory group are they part of? What security group are they part of? All of that information is automatically discovered by Tetration as it connects out into the wider infrastructure in your environment to learn about your applications and users. And you can see on the right-hand side of this slide a couple of the different examples of where we have automated controls to pull in information from external systems, but it's absolutely not limited to that either. In fact, Tetration has open interfaces where you can apply your own metadata. You can bring in your own knowledge about your environment and use that in your zero trust policy as well. So alongside this context-based inventory where we know about metadata, what we're also going to be discovering is huge swaths of telemetry about those machines. So we're going to collect information about every single flow that's happening in your environment. If you want to understand the behavior of an application or how a user is accessing that application, you need to see everything. You can't be doing sampling. You can't be taking spans or taps at choke points, at the border. You need to understand every flow. Most critically, those east to west flows between the different application tiers. If I don't have that, then it's going to be impossible for me to come up with a realistic and useful zero trust policy. If I'm trying to apply micro-segmentation between different application tiers, if I don't know every single flow, there's a very good chance I'm going to miss some sort of critical behavior. And then later on down the line, when that behavior is repeated, for whatever, if I don't have knowledge of that, that behavior is going to be broken, and that's going to break the application. And ultimately, the business is going to be very unhappy about that application being broken. I've done a lot of zero trust implementations with customers, and while it is critical to get to the point of zero trust, if you forgo understanding that the applications still need to run, that the business still needs to have the use of that application to go for this kind of shining star of zero trust, it's never going to be something that's going to work out well for everyone, because people are going to be disappointed by the fact that the application is broken. So it is critical to understand what that application is doing, what its normal behavior is, before you even think about doing anything like segmenting that application. Now, we send this metadata every second about every single flow. So the agent that Tetration uses is very lightweight. It doesn't take up loads of CPU on your workload, and all of the interesting processing is actually happening at the Tetration cluster level. Now, while flow data is incredibly important, and it's a major piece of understanding the behavior of an application, In fact, these days, flows is by far not enough to get the full picture. If I think about a typical data center, more and more the traffic is, switching over to things like port 443 HTTPS traffic. I might have my entire application communicating over REST APIs. So at that point, if I just have flow data, everything is just going to look like port 443 to me. But if I have the ability to go deeper, which Tetration does, and tie that flow data to the actual process, at this point, I've got a huge advantage when it comes to discovery and behavior of the application. I can understand that 443 traffic is being serviced by Nginx, or is it Python, or is it Java, or is it a Go binary? By going to that level of detail, I have a lot more insight as I generate policies, as I recommend information to you, because I can differentiate between the different applications and the behaviors of that workload. Alongside the process that is running and serving that network traffic, it's also critical to understand the posture of that machine. This is just basic housekeeping, right? What is the OS version on that workload? What patches does it have applied? What software does it have installed? Is that software up to date? All of this information is critical to building a behavioral profile of an application workload. So you're going to be getting all of this information sent to you from your workloads, whether those workloads are on-prem, in the cloud, whether they're bare metal servers, virtual machines, or containers. It's all going to be streamed up to Tetration in the same fashion, and you'll have that complete visibility. So alongside the workload telemetry, what we're then going to do is start ingesting all of this information in and beginning to bring insight to you. So this is where we get to wheel out the fancy buzzwords like machine learning, but it's really a tried and tested technique to help analyze that huge volume of data to come up with useful results. So what Tetration is going to be able to help provide you is automated zero trust policy discovery. Now, if any of you are kind of familiar with the, let's say, generation 1 of zero trust or microsegmentation products out there, there's a lot of products that shipped the capability to help you implement zero trust or microsegmentation. But none of them actually helps you understand what your zero trust policy needed to be. And from our perspective in Cisco, that's where we found that customers were really actually starting to find the trouble, the sort of roadblocks to actually implementing zero trust, which was that this organizations don't have this knowledge of what the policy needs to be. So you can have all of the different policy enforcement planes that you need, but without having a tool that can actually help you understand what my policy needs to be, you're never going to get to that point where you actually can implement zero trust. So what Tetration is going to do is look at your applications, look at the workloads out there, and it's going to perform two tasks. One is going to discover and group workloads together. Machines that are exhibiting the same behavior on the network are going to be clubbed together into their small microsegments. And that behavior is going to be based on all of that metadata that we previously saw. So it could be flow information, it's process information, it's packages and software that's installed, it's any tags that you might have applied to a machine. All of that information is correlated together to come up with smart judgments around what group or what workloads should be grouped together. Once those workloads have been grouped together, then by analyzing the huge amount of flow data that Tetration has, it's going to be able to help you understand and build out the rules between those different groups. It's going to suggest what those different network access controls should look like. And it's going to also help you analyze the effectiveness of those policies. If I install this policy right now, if I apply this policy, what traffic is going to be allowed? What traffic might be dropped? Am I going to be contravening any of my compliance rules? So all of this data will be made available to you in a simple and very easy to use package. Like Dave was mentioning, you can have all the technology in the world, but if it's not simple and easy to use, it's going to be impossible to actually implement it. So we've gone to great lengths with inside Tetration to make this data as accessible as possible, and something that's not going to require an army to validate and enforce these policies. It's going to be something that can be easily operated by a few folks, and it's going to leverage their capability and also the big data analysis capabilities of Tetration to really fast forward your zero trust implementation. Now, one of the most interesting things about the zero trust policy discovery is not just understanding the application and the relationships within inside the application, but one of the most critical parts of zero trust policy discovery is actually what is this application talking to outside of its scope? What services do I rely on? What core shared services do I need to be able to consume? What users are accessing my application? Is this internal users? Is it a subset of my internal users that should be accessing the front end of this application? By having that complete knowledge around everything that you have in your environment, you get this full picture of what your zero trust policy is going to need to look like. And it really helps you because I've walked into customer environments where the app team knows something about the app. The infrastructure team or the security team knows about what the standard security policies need to look like. But getting that full picture, understanding the entire set of rules is often something that neither team possesses. So by being able to use a shared tool where you can actually get collaboration between the application folks and the security and infrastructure folks, you get this ability to have the same single shared knowledge and repository of what your zero trust policy is going to look like. So with our automated zero trust policy discovery, the next step is to really help you also capture any of your business policies. So while you will have individual applications that have their application level policies, what we've also discovered through doing zero trust implementations is that most businesses have a set of rules that need to be applied everywhere. That might be basic regulations like things that we don't have trust, should never access any of my trusted workloads. Or it might be things like prod cannot speak to non-prod. Whatever these different policies are, typically you want to codify them in a way that is easy to understand and that can be applied consistently across every single application. So Tetration provides you a natural language policy definition engine where you're going to be able to write these policies in a way that is abstracted from ports and protocols and around identity and behavior. And then these are going to be dynamically applied in an ordered fashion and combined with your application level policies. So the security team, the centralized infrastructure team can focus on your compliance rules, ensuring that everything is up to scratch. And the application team can focus on the application level policies and ensuring that their web can speak to their app tier, which can speak to the DB tier. So you can have all of the policies that you would need to effectively implement zero trust combined into one central system. And what Tetration is going to do is actually combine these two different layers of policy into one final rule set. So you get this ordered hierarchical approach to policy that is combined in a deterministic fashion. And you're going to get at the end of this a single ordered prioritized segmentation list or allow list that is going to be able to be enforced. And this policy ultimately you want to enforce somewhere, whether that is via network controls or at the end host level. And in fact, in many circumstances, would recommend actually applying this policy in both of those places for a defense in depth. So the automated policy enforcement capability of Tetration allows you to actually, with one click, take what is being discovered by the system and apply it to every single workload that you have out there. So that agent is going to be able to go from a monitoring only mode into an enforcement mode. And at this point, it is going to take over the native host firewall, whether that's IP tables and IP sets on Linux or the Windows Advanced Firewall on Windows. And it is going to apply those segmentation rules right there at the workload level. This is a very scalable way to enforce segmentation and micro-segmentation, and it means that it is infrastructure independent. I can implement zero trust and implement micro-segmentation without having to touch any of my infra. I don't have to switch out my switches. I don't have to talk to my cloud provider and hit their APIs. All of this is sitting at a layer above the infrastructure, and it means that you get a consistent policy enforcement across every single workload that you have. It's going to be dynamically updated and continuously monitored for compliance. And if there's anything that looks abnormal, if there's any behavior changes, Tetration is going to capture that, and it's going to track that, and it's going to alert you about those changes in the behavior of the workload. And if necessary, it's going to cause policy updates so that that workload can react to that change in behavior. So you're going to get that segmentation. you're going to get that actual ability to apply microsegmentation across all of your different environments without having to lift and shift anything. On your on-prem bare metal servers, on your virtual machines, if you're using Kubernetes, you're going to be able to apply those same policies consistently. And this could be workloads that are in AWS, it could be GCP, it could be Azure, and it could be a combination of all at the same time. So it's a really simplified policy management and zero trust enforcement plane across all of your different workloads. I'm just going to take a quick example of a full zero trust user aware application access model so we can really break down the different parts about what Tetration is going to know. So if we look at the different components on the screen here, we have users that are going to be accessing applications, different categories of users, both members of my organization, subsets of my organization like finance users or IT admins. And Tetration is also going to have knowledge about the application, the web app DB components in this case, and details about how they communicate, their behavior, the profile of all of those different workloads. So we have the Tetration agent out there deployed on the application workloads. We don't have the Tetration agent on the user side, and the way that this works is by integrating with external systems of record. So whether that's LDAP, that could be Active Directory, this can be Cisco ICE. There's lots of different ways to feed user information to Tetration. But at that point, Tetration becomes aware of what users are in your organization, what devices are out there, and what could be accessing applications. That knowledge is then going to be percolated down to the application workloads, and they are going to modify their access lists, their zero trust policy based on the current state of the logged in users or the authenticated users. At this point, you can then control segmentation policy. You can control the zero trust policy for an application. You can say things in Tetration policy like only finance users can access this web application. You can go down to the Active Directory group. You could even go down to the individual username of a employee and use that as the policy. It's going to be dynamically updated. As a user logs on, as they log off, it's going to cause a cascading effect to update rules across your entire environment and make sure that everything is perfectly up to date. What it's going to be doing is reducing the attack surface at the same time. If I'm restricting this application to finance users only, even users on my corporate network can no longer access this application anymore. That helps dealing with that insider threat. Why should I be having folks from my engineering team accessing a finance application? It shouldn't be the case. And so that really helps you lock down the attack surface of that application and truly move to that zero trust model. Folks inside my organization are going to be treated in the same way as folks outside of my organization. So that's really where we're starting to see that zero trust coming into play. Now, what's also cool is while the finance users might be accessing the front end of the application, I can also allow a different subset of users to access the application in a different way. Here, I might want to have my IT administrators be able to access SSH ports on all of my different application workloads so that they can go and do some troubleshooting if necessary. So I can have conditional access applied to workloads based on the behavior or the identity of a user. And so with my final slide, what I'm going to do, and I'm just going to throw this up here really for reference. You can go look at it in more detail later. This is mapping Tetration to the NIST zero trust architecture. So this is kind of like an idealized architecture of what you might want to have in place if you're going to implement zero trust. It's going to walk through the different components that Tetration has, like learning identity from workloads, being able to bring in custom annotations, custom metadata. That could be from all of these different systems of records, which we have automated capabilities to pull information from. You can combine that with compliance rules like PCI compliance rules. You can combine it with threat intelligence so that you can be aware of emerging threats that might be progressing across your network. You're going to have full information into every single flow, every single user, the devices, how they access that, whether it's on-prem or in the cloud. You're then going to be having the Tetration agent, which is going to be able to enforce those policies at the workload level and also publish them in an open format so that they can be enforced in infrastructure components. And so that means that you can be segmenting, physical servers, virtual machines, appliances, workloads up in the cloud, containers, everything above, you're going to be able to enforce zero trust policies on. And it's all going to be performed in an easy, simple interface that's utilizing big data, and it's going to be able to send you alerts if necessary. So with that, thank you very much for listening to my segment of the presentation. I think we're about to wrap up now. I don't know if there's a minute or so for any questions, but again, thank you very much for listening today.
All right. Well, unfortunately, we don't have time left for the Q&A. However, I want to reassure anyone that has submitted questions that I'll make sure that they get over to Cisco so they can reply to you directly. So thank you so much, Dave and Tim, for your great presentation, and to Cisco for sponsoring this webcast, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.